All right, today I hope that you guys have been able to figure some things out about isosceles triangles. You have just used your 3-in-1 for like the last 20 minutes. You have been looking at the properties of this. On the very first page, you created a circle. You created a triangle inside the circle. You had side length AC and side length AB. Those are both radii. Each one of those is a radius of the circle, correct? Because both of those are a radius of the circle, you know that those two are congruent, like this. AC is congruent to AB because they're both radii of the same circle, okay? That's the reason that you know this is a isosceles triangle, because two or more sides are congruent, okay? You went through and you actually ended up measuring the angles and everything else, and you should have come up with some sort of conclusion here at the bottom, this conjecture, saying basically if a triangle is isosceles, then the base angles are congruent. You were measuring it. In picture form, this is basically what it means. If you have the two sides are congruent, like this, and the sides opposite, or the angles opposite them, are also congruent, just like so. Okay? Now, on the second page, you are doing the reverse of this, and basically the conclusion here looks like this. If a triangle has two congruent angles, then the sides opposite those base angles are congruent, okay? So the idea is if you have these two base angles, the side opposite them is basically across from it, so this one would be over here, this one would be over here, okay? Then those two sides are going to be congruent, okay? It's at the very bottom of the second page, I think, okay? Converse of the isosceles triangle conjecture, okay? Those are the things you should have gleaned from the very first page of this. And the next page that we're going to look at is basically the application of this, okay? And the two things really keep in mind, if you want to just look at them really simply, is if you have the two sides, then you have the two angles. If you have the two angles, then you have the two sides. And it's going to keep going back and forth between that. We're also going to couple this with the idea of the triangle sum theorem, which we learned yesterday, that basically says that the three angles of a triangle are always going to add up to 300 or to 180. Okay, so the very first one, if we're on the next page here, we know because of these sides being congruent that this angle and this angle are both going to be congruent, so this has to be 58 degrees. Is that what it's asking for? It's not, okay? So then we need to actually use just the triangle sum theorem in order to come up with the other angle. So I'll say 58 plus 58 plus the measure of angle T equals 180 degrees. Okay. I'll add 58 and 58 together, I'll get 116 plus the measure of angle T. That equals 180. The measure of angle T is basically just some variable. It means the measurement, whatever that measurement is. I'll subtract 116 from both sides. This would be 64 degrees. So the measure of angle T would be 64 degrees. I'm going to make sure to also put this on the line that it gives me, just like so. Does that make sense to everybody? So the idea here is, because of these sides, we can talk about the angles. Because we have two of the angles, we can find the third one that's up top here. Okay? Pretty similar concept with the next one. Because we know these two sides are congruent, we know that these two angles are congruent. I'll just put little x's there. We don't know what they are, but we can put little x's there to kind of to symbolize them. What does this box mean right here? 90 degrees. So basically I have x plus 90 degrees equals 180 degrees, just using the triangle sum theorem. Okay? In other words, this is 2x plus 90 equals 180. If I subtract 90 from both sides, I'd have 2x equals 90. If I divide by 2, x will equal 45 degrees. It's asking me what the measure of angle G is. Well, that's the same as x that I put up there. I'll say this is 45 degrees. Am I going too fast? All right. The third one up here is going to be, it's a little bit different because there's several different concepts we're looking at. The first thing, because both of these are a linear pair, because these two angles here are a linear pair, I can actually say this angle right here is 70 degrees. Okay, so this is 110. This one right here is 70. They are a linear pair. They're supplementary. Basically, 110 plus the 70 has to equal to 180. Does that make sense? You label that as 70. Okay, and then this angle down here, I'll call it Y. This angle right here, I'll call it Y. Okay, those two are going to be congruent because they are the base angles of this isosceles triangle. Is that okay? So I would know that 70 plus 2y has to equal 180. Is everybody okay with that equation that I just wrote down? 70 plus 2y. And I think it's okay to create these variables, just like yesterday we had to create a variable on, I think, number 9 or 10 of the assignment. We had to create like a W or something for it. The idea is I create the y's just so that I have some way of talking about this. Yes, ma'am. Yep, before we can solve for x, we have to do some other stuff first. Okay? Because if we figure out what y is, then we just know that those two are going to be supplementary angles, we'll be able to figure out what x is. Okay. If I subtract 70 from both sides, this would be 2y would equal 110. If I divide both sides by 2, I'd get y equals 55. So this angle right here is 55 degrees. Because these two are a linear pair, they're right next to each other, I know that 55 plus x, whatever x is, has to equal 180 degrees. The same logic that I used here right at the beginning to get the 70. So if I subtract 55 from both sides, x would equal, let's see, 125 degrees, like so. And I'll also put that on the line. So some of these get really, really involved that there's about a 3 or a 4-step process in order to figure some of these out. Generally speaking, we'll see about a 2-step process, but some of these will have 3 or 4 steps, kind of like this one's kind of weird. We had to figure out the 70 first, then we had to figure out the y's, then because of the y, we could talk about supplementary angles. That's definitely a 3-step process. Yes, ma'am. Yeah, both of these would be 55 because they're both y. You also know that because they're the base angles of this isosceles triangle, this triangle right here. Even though it's slanted, and it doesn't necessarily look like it's an isosceles triangle, you have to trust the markings that tell us it's an isosceles triangle. Is that okay? Okay. Any other questions on this? Hey, Nick, can you get back to your seat? Thanks. Okay. So next one, what do you guys want to do for this guy? Just need a volunteer to set up an equation. Please. Yeah, 68 plus 60x, 8 plus the measure of angle r. You could call it x if you really wanted. Just make sure to label that on the picture as well when you do it. Equals 180. If we were to add these together, that'd be 136 plus the measure of angle r equals 180. If you subtract 136 from both sides, Alice, what do we get? We get 44 degrees. And that's our answer there. Make sure that you label this correctly with degrees. The second thing, since both of these are 68 degrees, that also tells me that these two sides are congruent. If I have the angles, I have the sides. Okay. Notice another thing, this triangle isn't faced the same direction that we always look at these triangles. This one's kind of slanted. Okay, it's not a huge deal. That's fine. If this is 35 degrees over here, what does this side have to be over here? 35. And I think I said it wrong. I think I said degrees. Make sure to label it centimeters. Okay, and we're dealing with 35 centimeters. Okay, there should be a label for everything. It's either degrees or it's some sort of units of length, such as centimeters for this one. Middle one. Middle one's pretty similar. Let's do the measure of RD first. By the way, if there's no symbol above it, it doesn't mean the length. So when it says just RD up here, when it says RD, it has no symbol above it like line segment or line. Then it just means the length of RD. So what's the length of RD? Yeah, 3.5, and again, centimeters. Make sure to use the proper units for these. And if I label both of these x, because I really don't have a good way of notating it otherwise, I can say this is 2x plus 28 equals 180 degrees. I think you guys feel pretty comfortable with that. You just need to kind of create some sort of variable here in order to represent those angles. And then we're just adding them all up to equal 180. This would be 2x equals 152. If you divide both sides by 2, that is 76 degrees. And I'll also put that up here, 76 degrees. Is that all right? Okay. The last one, number 6, has a little bit more going on. Okay, there's a little bit more going on with this one. I'll probably use a lot of space for this one. It says the perimeter of triangle MUD is 36.6 centimeters. Okay, well, I know this is 14. I know this one over here has to be 14 centimeters because those two are congruent. The markings tell me that. I'll know this is 72 degrees. But I don't know how long MD is, so I'm just going to say 14 plus 14 plus MD. Remember, that means the length of. And that has to equal, what does that have to equal? Does it equal 180? Oh yeah, 36.6. Basically, if you remember, the perimeter is just adding all three sides together. Okay, it's adding all three sides together. This would be 28 plus MD equals 36.6. If we subtract 28 from both sides, we would have 8.6. Is that correct? Okay, and that's one of the things it asks for, so I'm going to write this up here. This is 8.6, and again, centimeters would be the best way to write. Measure of angle D is pretty easy because we know that these two sides are congruent. We know the two base angles are congruent, so this is just going to be 72 degrees. The last thing we need to do, though, is we do need to add these two together, so we'd have 72 plus 72 plus the measure of angle U. That all has to equal 180 degrees. So that's 144 plus the measure of angle U equals 180. When I subtract 144 from both sides, the measure of angle U becomes 36 degrees. I'll also put that up here just to make sure that I know what's going on. Yes, sir. Actually, I added them up to get the 144 right there, and then I subtracted 144 from both sides. Yep. So in essence, I subtracted both 70. That's right. Okay. We just went through 6 problems. You guys went through on your own the exercise to really get those theorems to begin with. If you remember right, with the theorems, the idea here is that if we have a triangle, if we have the two sides like this, we're going to get the two base angles. If we have the two base angles like this, we're going to get the two sides. Okay? That's the basic concept of an isosceles triangle. That's the relationship between the sides and the angles. Okay? Your homework for the weekend is to do, it looks like 1 through 3, and then I think it starts renumbering, starting with like 1 again, and it goes like 1 through 9. I will randomly pick 10 of these that we need to solve completely to get those items. That's what will be graded on Monday.